Alright, so what we're going to do is a little algebraic manipulation right now, just to see where the next formula we're going to use comes from. And again, this is on the formula table that is in the book. And so we have a z-score is equal to the continuous variable value, the continuous random variable, minus the mean divided by the standard deviation. Well, we're working on this idea that we want to, right, if this is our forward direction, we want to go backwards. And we've been able to go from probability to z-score. We want to go from probability all the way back to x. And so we need to solve this for x. So I'll take the equation down here, and I'll write it, and I'll do each step in a different color. So I want to get rid of the standard deviation on the bottom, so I have to multiply by the standard deviation. But whatever I do to one side, I do to the other. And so I have z times sigma equals x minus mu. And now I want to isolate x on its own. So I'm going to add mu to this side. Those two should cancel out. But whatever you do to one side, you do to the other. So I'm going to add a mu over there. And all said and done, I have z, well, mu plus z sigma equals x. Or if we read it from left to right, the mean plus the z-score times the standard deviation gives you your continuous variable. And this is the formula that we jump to on our sheet when we want to go from a z-score to an x value. So, for example, a veterinarian has weighed some cats. Where is this going through here? A veterinarian has weighed some cats, and what the veterinarian has found is that the cats are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. And so what we want to do is, hey, if I have a cat that is a z-score of 1.96, what's its actual weight? Well, so I go to the formula, I say x is equal to the mean plus z times, whoops, z, that's not a full z, z times the standard deviation. So in this case, it's 9 pounds plus 1.96 times 2 pounds. Notice our units stay the same, pounds and pounds. And so 2 times 1.96 is, let's see, calculator. I'm not going to pull it up, I'm just going to punch this in on the calculator. And I get 12.92 pounds. So a cat that's in the z-score of 1.96 is going to be 12.92 pounds, right? Positive z-score should be on the larger side. So let's look at the same thing if we had a cat that had a z-score of negative, whoops, z equals negative 0.44. So its x value would be mu plus z times the standard deviation. So the 9 pounds stays the same. We're going to change signs here because it's a negative, times 2 pounds. And we run to our calculator and we get 8.12 pounds. And so a cat with a z-score of negative 0.44 would be 8.12 pounds from the data this veterinarian did. And so that formula drives what we need to do. All right. Well, here's another example, and I actually like this example and dislike it for 2 different reasons. So the scores for the California Peace Officer Standards and Training Test are normally distributed. So we have scores for a test normally distributed. And what an agency wants to do is it only wants to hire the top 10% of the scores. And so if in a particular test batch the mean is 50 and the standard deviation is 10, what's going to be the score that you need to get? What is the x value, the score you need to get to be hired by this agency? And so what we're looking at here is we want the probability of everything up to 10%. Or we want the 90th percentile, right? There's different ways we can say this. Right? And so we want this side of it here, which would be the 90th percentile group. So in our case, it's going to be 1 minus 0.1 is our probability value. Sorry. And so our probability is going to be 0.9. And so we want to find the z-score associated with a probability of 0.9. Now we can look at this on our calculator. We can look at this on the table. I'm just going to pull the value that I have here from the table of 1.28 roughly. And so we have a z-score of 1.28. Right, on the table, I think the closest thing is 8997. And so our x value, or the test score we want, is the standard deviation plus the z-score, or not the standard deviation, the mean plus the z-score times the standard deviation. And 10 times 1.2, whoops, 1.28 is 12.8, right, because we move the decimal place over 1, or 62.8, right, is what you need on the test score here. Alright, so this is how we can go from probabilities to actual continuous variable values. We use this new formula that we have worked out that will give us the x value if we know the mean and the z-score. And so now we have tools to go backwards and forwards with our data.